streaks on the slopes of a crater. Mysterious lines that appear to change with the seasons. On September 28, 2015, NASA scientists announced their groundbreaking conclusion.
What we're going to announce today is that Mars is not the dry, arid planet that we thought of in the past. Today we're going to announce that under certain circumstances, liquid water has been found on Mars.
Scientists have never found liquid water on a surface anywhere beyond Earth. The discovery is historic.
Life as we know it on Earth needs liquid water to survive, so that's kind of the key first thing that we need. But we also need organic materials, and so those are some basic elements like carbon and hydrogen and oxygen.
In 2012, a rover called Curiosity landed in an ancient Martian lakebed known as Gale Crater. A roving chemistry lab, Curiosity drilled into the soil in search of organic molecules.
One of the last pieces in the puzzle with Mars is that we'd never been able to detect the presence of organic molecules. And Curiosity put that puzzle piece in. We know that there are organics in the soil.
We also discovered, and this is really important, we found an environment that wasn't very acidic, and that was really our first discovery of a habitable environment on Mars, where we think life could have existed.
We have found evidence of water and organics. But were they both plentiful on Mars for billions of years? Perhaps even long enough for life to take root. Mount Sharp, the 3-mile high peak at the heart of Gale Crater, may hold the answer. It is a time machine. The higher up the slope you go, the further back you travel in Mars's geological history.
We really were looking to Mount Sharp to tell us the record of environmental change through Mars's history. We think that there's a possibility that as you go up through the layers of Mount Sharp, we may be exploring different habitable environments. And so what we're interested in finding out is how does the habitability as a whole change through time?
Today, Curiosity is entering a new phase of exploration by climbing Mount Sharp. Along the way, it will analyze the soil, piecing together 3 billion years of Martian history. But for rover driver Matthew Heverly, the path ahead is fraught with danger.
We're always pushing the limits of this vehicle. I mean, the rover's amazing. It can handle so much. But as we go to Mount Sharp, we've got some pretty gnarly terrain to head over.
There we go.
To find out just what kind of terrain Curiosity can handle, Matthew and Katie take a rover out for a spin.
So we built 3 rovers. We sent one off to Mars. We built an exact copy that we keep here on Earth for testing software and cameras. And then we built another one, Scarecrow, because we have to adjust for gravity.
Mars's gravity is 3/8 that of Earth's, so Curiosity's 2,000 pounds become about 750 on Mars.
Scarecrow rover is stripped down, but it weighs on Earth what Curiosity weighs on Mars. So it's got the right ground pressure, it's got the right, as we're going up a hill, it's carrying the right amount of weight up that hill. So we can test in the Mars yard, how steep a slope can we climb up?
Satellite photos reveal that the most direct path up Mount Sharp would take Curiosity through sand dunes. So Matthew and Katie decide to see just how much sand the rover can take.
Sand is scary for us because we think we understand what's going on, but we get constantly surprised. What angle do you have there?
We're at like 16.5.
We would not do this much slip in operations unless we were very sure we could get out.
Yeah.
And then it just gets harder to extract yourself.
What we're learning is that the sand dunes are really just too great of a challenge for the rover to handle. The rover actually does a better job with the steep rocky slopes.
The team chooses a path around the dunes, and Curiosity continues on its journey up the slope of Mount Sharp. Will Mars prove to be a planet where life once thrived? Only time